Section 2.3, Finding Domain and Range. The solutions of an equation in two variables consist of a set of ordered pairs. So we're asked to find the domain and range on this particular graph, and we have the horizontal axis is x. For the first point on the far left, x is -3. For the next one, x is -1. X is 1 here, and x is 3 there. So we can say that the domain is the set of discrete values, -3, -1, 1, and 3. How about the range? The range will be the set of all possible y values. Y is the vertical axis, so looking at the topmost point, it looks like y can be a +4. Next point down, y is 3. Next point down, y is 2. And the bottommost point, y is a -2. So our range will be the set of values -2, 2, 3, and 4. That's our range, all possible y values. Next example, we're supposed to determine the domain and range of each correspondence and whether or not it is a function. So we have two examples here. The top one, domain, what are all possible x values in these sets of ordered pairs? So it looks like x is 1, we'll put them in order, 2, 3, and 4. Range, all possible y values. Y is -3. Y is 1. And y is 5. So that's our range. Is this a function? For every x, is there one and only one y? Yes, it is a function. Our next example, here, we have our domain, all possible x values, -2, -1, 0, 1, 2. Our range, all possible y values, -4, -3, 0, 3, and 4. Is it a function? For every x, is there one and only one y? Yes, it is a function. Let's look at this graph and do the same thing. We need to come up with the domain. What are the possible x values? We see some points at 1, at 3, and at 5. So our domain will be the set 1, 3, and 5. How about the range? We see a point at 1, 2, 3, 4, and 5. So our range will be 1, 2, 3, 4, and 5. Is this a function? For every x, is there one and only one y? How about here? We have x is 5, y is either 3 or 4. How about here? We have x is 1, y is either 2 or 5. It is not a function. It fails the vertical line test. Let's abbreviate that. VLT, vertical line test. Use the graph of the function to answer the following questions. Give all answers to the closest integer value. That is, no fractions or decimals. So give the domain of this function. What is the domain? Remember, domain is x values. How far right and left can it go? Well, to the left, it goes all the way over to -2. To the right, it goes all the way over to 6. So we can say that the domain will be all x values between -2 and 6. And it can be equal to those. What about the range? How far up and how far down does this graph go? It goes up to 2, it goes down to -2. So our range will be all y values between 2 and -2. Find f of 5. What is the function evaluated at 5? So x is 5. 1, 2, 3, 4, 5. There's our graph, f of 5. This is the point 5, 1. So f of 5 is 1. For what value is f of x equal to 0? Well, we need to know where f of x equals to 0. That means y is 0. That happens 2 places, here and here. So what are those x values there? -2 or 1, 2, 3, 4. -2 or 4. Given the graph of correspondence, that is a function f, determine its domain and range and sum of its pairings. So this is our graph. We want to know what is the domain. Remember, domain will be x values. How far right and left can the graph go? So it looks to me like it goes back here to -2. How far right? It goes up to +2. So the domain will be x has to be between -2 and +2. What's the range? How far up and down does the graph go? It goes down to -1 and up to 3. So the range will be y has to stay between -1 and +3. f of -2, what is the function evaluated at -2? X is -2. That happens right here at the point -2, -1. So f of -2 is -1. What is y when x is -2? That's another way of stating that. F of 0, another way of saying that is what is y when x is 0? X is 0 right here. What is y? Y is +1. Find all x such that f of x equals 2. F of x equals 2. So f of x is another way of saying y. So y is 2. If y is 2, that's this point right here. Y is 2. So x must be 1. Let's look at our next example. We want to find the domain for this. The question is, how far right and left can the graph go? Well, the graph can go to the right as far as you want, to the left as far as you want. So we'll say the domain is all reals. It can be any real number. What about the range? How far down can this graph go? Looks like it goes down to -1. So the range will be y has to be greater than or equal to -1. It can go as far up as you want. What is f of 0? When x is 0, what is y? -1. What is f of 3? When x is 3, what is y? 2. What is f of -2? When x is -2, what is y? +1. Find all x such that f of x equals 2. F of x equals 2, the function f of x is the same thing as saying y, so where f of x is 2. That happens here, but it also happens here. It happens in two different places. F of x is 2, so x is -3 or +3. Find all x such that f of x equals 0. That also happens in two different locations. Y is 0. It happens here, and it happens here. So x is -1 or +1. When a function is given by an equation or formula, the domain is understood to be the largest set of real numbers, inputs for which the function values, outputs, can be calculated. To find the domain of a function given by an equation, find all possible values of x, or think, what can we substitute? So find the domain for each function. So looking at our first example, f of x equals x squared plus 1. Think about what can x be. Can x be positive? Sure. Can it be negative? Yeah. Can it be fractions? Sure. 0? Yeah. Integers? Yeah. So x can be anything. All reals. All real numbers. That's our domain. Look at this next equation. F of x equals x plus 2 divided by x minus 4. The problem I have with this is its division, and I know that we cannot divide by 0. What value of x would make this denominator 0? We can't have it. X minus 4 cannot be equal to 0. So x cannot be equal to 4. It can be anything else, but not 4. So that's our domain. And in general, in domains, we want to avoid division by 0. What about our third example? G of x equals x plus 4. X can be positive, negative, 0, fractions, all reals. All real numbers. That's it for this section. Go to the next tape if you need the next section.